Welcome, y'all. Back to some more geometry. Today we're talking about distance and midpoint. Let's kind of talk about both of them. So distance is the link between two places, from one spot to another spot. As we'll see here in a bit, we'll kind of go over a map. The midpoint is the halfway mark between 2 points. So for example, right here, this is, where is it at? Right here. This is Gaiman. Hopefully some of you guys know what Gaiman is. Gaiman. And this is liberal. Hopefully you guys definitely should know where that's at. This is a map of Highway 54. Now, what is the distance from here all the way to here? The great thing about this is it's mostly a straight line. Anybody? No? Oh, okay. Well, it is 40 miles. 40 miles from here to there, both either way, forwards or backwards. Now, that's the distance, okay? Now, when we talk about midpoint, what is the midpoint? Midpoint. We're saying, hey, what is 20 miles from Gaiman? 20 miles. And what is 20 miles from Liberal? You're right. It is Hooker. Hooker is the midpoint of Liberal and Gaiman. And you can break that down even more. Hey, what's the midpoint of Hooker and Gaiman? It's a little town called Optima. This is where I'm from, actually. Oh, not from, but this is where I live. And the halfway point between Hooker and Liberal, the midpoint, is Tyrone. This is 10 miles, 10 miles, 10 miles, and 10 miles. Now, anybody know why there's 10 miles from Liberal to Goodwill? To Gaiman. And actually, it goes all the way down here to Texoma. That's 20 miles from Gaiman, and there's Goodwill right there, which is 10 miles. So, back when the railroad stations were being laid down, they needed resting stops, pickup stations, drop-off stations, and get water every 10 miles. So that's why every 10 miles there's a town that follows the railroad station. Fun fact. All right, but let's move on. So let's talk about the distance formula. Most of you may have seen this before, but in case you haven't done it before, let's kind of go over it. So there's two main parts. There's your x's and your y's, and that breaks down to two parts: x1 and y1, x2, y2. These are what we get these from order pair. They're order pair. If you don't remember ordered pair. Sorry, it looks horrible. Pair. Now, order pair is a set of coordinates in the form of x and y that can be graphed on a graph. This is called Cartesian graph. It was created by Rene Descartes. Called a Cartesian graph, where the center is the coordinate 0, 0. Anything to the left or right, that's on the x-axis. Anything up or down, that's on the y-axis. So for example, this point, you always do your x comes before y. So they did negative 4, 3. It's because they went negative 1, negative 2, negative 3, negative 4, and then positive 3. 1, 2, 3. That's how we get the coordinate negative 4, 3. And this one's 8, negative 2. 8 on the x-axis, negative 2 on the y-axis. All right, so what's x1 and y1 and what's x2, y2? You pick. So I'm going to call this set, kind of going from left to right. This is going to be my x1, y1. Every set of points, every point is an x1 and an x and a y. So if that's x1, y1, I'm going to make this x2, y2. That's my other xy coordinate pair. So the distance formula states this. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the great thing about this formula, it's set for you. You work it from the inside out. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So this is the first thing you do. This is the second. These two do left to right. So multiplication, division. So this is the third thing you do, and addition, subtraction is the last thing you do, the fourth thing you do. So let's go ahead and plug in our x2. So we're calling this set the x2, y2. So we start with that. So distance equals the square root of x2, which we're calling that 8, minus x1. x1 is negative 4. So you have to include that as this whole other thing, negative 4. Understand, that minus sign is part of the problem, not part of the number. So This has its own negative sign, so minus a negative 4 quantity squared plus y2, which we said is negative 2, put a comma, minus the value of y1. y1's 3 quantity squared. So as it says, we start with parentheses. So in here, we work this out first. So 8 minus the negative 4 means they switch to positive. So it becomes 8 plus 4. We get 12 squared plus negative 2 minus 3. Because they have the same sign, you add the number. So negative 2 minus 3 gives us a negative 5 quantity squared. Of course, we still have the big old square root over the whole thing. So let's square these numbers. So next thing is exponent. So 12 squared means 12 times 12. You get 144 plus 5. Negative 5 times negative 5 is not negative 25, y'all. Negative times a negative is a positive. Negative 5 times negative 5 gives us a positive 25. Quantity square, you add them up, you get the square root of 169. Once we have a solid number, we square root. So what two numbers multiplied together gives us 169 that happens to be the same number? Yes, you're right, it is 13. So this is 13 units long. From here to there, 13 units long. Now, irrational numbers are numbers that cannot be expressed with a terminating number or a repeating number. So for example, if you ever put a radical 2, it gives you a crazy set of numbers that don't repeat or anything. Like 1/3 is a rational number because it's a repeating number. It's equal to 0.33 repeating. That's okay. Radical 2 is not. Pi is also considered an irrational number. You cannot do it. All right. Next thing is the midpoint. Like we said, the first part was distance, which we just did. The next thing is midpoint. Midpoints. So with midpoint, you still have a set of x and y. So x1, y1, x2, y2. But this time, we're gonna set it up. We're gonna find another set of coordinates. We're gonna call that the xm, ym. Means the x midpoint and the y midpoint coordinates. The x and y for the midpoints. That's why I call it xm, ym. Now, to get that, we're going to add the value of x1 and y and x2, and then divide by 2, and add the value of y1 and y2. So this is, again, x1, y1, x2, y2. Okay, so as we have right here, this would be our, actually, let's do this one. I keep forgetting to change that because that, for some reason, these fours confuse people. So I'm just going to do this one. This is our x1, y1. This is our x2, y2. All right, so we're going to take the value of our x's and add them. So we'll do negative 3 plus a negative 7 over 2, comma, y1, 7 plus a negative 5, which is y2, over 2. And again, we're getting a set of order pair, so the coordinates. So it's still parentheses. So negative 3 plus a negative 7. They're both negative. You add the number, you get negative 10 over 2, comma. And 7 plus a negative 5, because it's plus a negative, you're subtracting 7 minus 5. And you're getting positive 2 over 2. So you got negative 10 over 2, comma, 2 over 2. Reduce that, you get negative 5, comma, 1. This is our new x, m, y, m, our coordinates for our midpoint right there. Let's look at this one. This one has a b in it. Let's see what's up with that. So this is our x1, y1, x2, y2. All right, so we're going to add those two. So we still set up x1, 2b, plus x2, which is 4 over 2, comma, y1, 3, plus y2, negative 5 over 2. Okay, so can we add 2b plus 4? Can we do that? No. So we just bring that down as it is. Plus 4 over 2. 3 plus a negative 5, you can't do this, so it's 3 minus 5, you get negative 2 over 2. We'll start with this. You can reduce this, so negative 2 divided by 2 is just negative 1. But let's look at this. Can we reduce this? Can a certain number go to all three numbers? Yeah. 2 can reduce into all of them. So 2 goes into 2, becomes 1, 2 goes into this 2, 1, 2 goes into this, becomes a 2. So we end up having 1b, or just b plus 2. And that's our ordered pair right there, y'all. Now, it's not exact or perfect, but it is reduced as lowest form. So there's be problems with just to reduce it. Okay, so be mindful of that. But that's it. Our two things we talked about today is, of course, distance and the distance formula. This always tells you how far two things are by doing this formula. And the midpoint will always tell you the middle coordinate of two different points. All right, y'all. Have a great day. Bye.